Optimization problems are problems that involve finding minimums or maximums. We're trying to find the smallest amount or the largest amount for our system. So we could have a circle, x squared plus y squared equals 1. And that circle's graph, since it's a circle at the origin with the radius of 1, looks something like this. And we could have the point 2, 4, and we could want to know what is the distance, the minimum distance between these two. Right? So there's some point on the circle, whose coordinates at this point are just simply x, y, that's closest. We want to know what that point is. So we know that the distance is equal to the square root of 2 minus x squared, or x minus 2 squared, plus 4 minus y squared, or that the distance squared is equal to 2 minus x squared plus 4 minus y squared. And here's a couple things about optimization problems. They're the kinds of problems you just need to practice a lot, because the hardest part is just coming up with the right relationship, and there's no great way of telling you how to do it. You just need to practice. What is the relationship I need to find the minimum maximum of? And we're just going to say that d squared is equal to a different function, a related function, d. And we're really just trying to look at this relationship of x and y. So we can expand this and find that the equation we're working with is equal to x squared minus 4x plus 4 plus y squared minus 4y plus 16. And we still have the issue of multiple variables right now. And we have to recognize that from our original equation of x squared plus y squared equals 1, we can know that y squared is equal to 1 minus x squared, and that implies that y must be equal to the square root of 1 minus x squared. So by substitution, we can find that with our original equation, we would have x squared minus 4x plus 4. We know that y squared is equal to 1 minus x squared. We know that y is equal to the square root of 1 minus x squared plus 16. And if we clean this up, the equation we're working with is equal to negative 4x oops, found a mistake. So this should have been 8y, which means this should be 8 times 1 minus x squared. So negative 4x minus 8 times the square root of 1 minus x squared plus 21. And we're focusing on the first quadrant. What's the shortest distance? We can restrict our interval to be between the x values of 0 and 1, because those would give us our bounds of what's in the x quadrant. We know that minimums occur when the derivative equals 0. So the derivative of d is equal to -4 times -4 times 1 minus x squared to the -1/2 power times -2x by the chain rule. Which means if we clean this up, we would arrive at -4 over 1 minus x squared to the 1/2 plus 8x all over 1 minus x squared to the 1/2. And what's happened is we had to get a common denominator in order to arrive at this. We want to know when this equals 0. This will equal 0 when our numerator equals 0, or when 4 times 1 minus x squared to the 1/2 equals 8x. Or dividing both sides by 4, when 1 minus x squared to the 1/2 equals 2x. If you square both sides and simplify, you'll find that x equals a number of things, but one of those things is √5/5. And that would be the only x value that's in the interval 0 to 1. So we've got 3 points we need to check in terms of minimums. 0, what is d of 0? Because that's our endpoint of our interval. What is d of √5/5? And what is d of 1? And whichever one is the smallest is the minimum. D of 0 is 13. D of √5/5 is about 12.06. D of 1 is 17. This means the minimum value occurs when x is √5/5. And if we plug that into our original equation, x squared plus y squared equals 1, we'll find that our point, √5/5 to √5/5 is the closest to 2, 4. Right? You really ought to practice a lot of these, because the hardest part is just getting the relationship more than anything else.